Okay, so in this video, we're going to talk a little bit about force vectors. And you see an objective there that students will add forces and resolve them into components using the parallelogram law. Students will compute a resultant vector adding two or more vectors. We're also going to be discussing a little bit about just what a scalar is, what a vector is, how to multiply vectors or the vector of operations between those two. And then we're going to have some drawings of the use of the parallelogram and the use of head to tail in order to compute a force resultant and the direction of that force resultant adding two vectors. But first, let's just talk a little bit about a scalar. And a scalar is a positive or negative physical quantity that can be completely specified by its magnitude. So it's a positive or negative physical quantity. And what we can think about is something like temperature, right? In the summer here, it's 100 degrees, right? In the winter, we might, well, not here, but in Alaska, maybe we get down to negative 32 degrees. That's cold, right? Or we can look at length, 100 feet. Or you could look at time, 10 seconds. Those are all a physical quantity. Now a vector, well, this has magnitude and direction. So if we drew a quick little axis here, and we have a vector that we're going to draw, let's draw like so. And we can say, all right, we'll call this a unit, all right? That's a unit of length or a unit of force, we could even say, right? If this is a force vector, this might be 1, 2, 3 newtons. If this is 1 newton, that unit is 1 newton. We'd also be given this angle, and we'll just call this 60 degrees. So here we have a vector shown on an axis, so a positive x, a positive y. And what we're going to be doing here is we're going to be breaking this vector into its components in order to add to a different vector so we can find its force resultant. But before we do that, let's talk a little bit about how we draw this. Now the head of the vector is right here at the tip of that arrow, and the tail is right here at the bottom, and for our sake, it's at the origin of this axis. And in this class, we're also going to talk a lot about the line of action, where this force is going along this line, and we call it the line of action. Right? Now let's just talk about vector operations. When we talk about vector operations, we're talking about multiplication of vectors. If I have vector A, and let's say I draw it like so, that's vector A, and let's say I want to multiply vector A times 2. Well, now I'm going to double that vector, right? So that vector now is going to be twice that size. So this is vector A, this is vector A times 2. If I wanted to multiply vector A times negative 1, well, now it's going to be the same vector, except, a little long there, except that it's going in the opposite direction. So let's talk about that. If I've got this vector anywhere along here, I just draw this vector here, all right? And when I have this vector here, and I look at quadrants, quadrant 1, quadrant 2, quadrant 3, and quadrant 4, we can look at the sense of this vector. Now this vector is down, right? It's going down and to the left. That's the sense, meaning that if it's going down, that's a negative y. To the left, that's a negative x. Now if we drew the vector over here, well, we could say that this is up, positive y, and to the left, which is a negative x. And if I have my vector over here, Well, the sense is up and to the right, and my vector over here would be to the right and down, or down and to the right. So here are positive x, positive y, and over here we have a positive x but a negative y. So that's something to think about when you're breaking these up into its components in order to add them up and to find our force result. So let's take a look at this here. So I've got two vectors. I'm actually going to, let's go ahead and redraw. Sorry about that. Go ahead and redraw that, just so we can see it a little easier. Let's see. And so we got vector B. And now that I have these two vectors, if I wanted to draw these head to tail, I could do it in two ways. I could draw, let's do these down here. I could draw vector B, and then I could draw vector A. This is vector A. This is vector B. If I drew vector A first, then I could draw vector B at the head. So we're going head to tail, so head to tail of B. Now you notice we've got a force resultant here now from the origin to the head of that second vector. Now I could also do it the opposite way. I could start with vector B. And if I start with vector B and then draw vector A, we're going to land up in that same point. It doesn't matter which vector, which way you draw, which one you draw first. Again, this was vector A here. This is vector B. And over here we had vector B and vector A. So it doesn't matter which way you draw them out. You're going to get the same vector here, or the same force resultant. It's going to be the same. Now, we could also draw this in the parallelogram. So if I were to move vector B, copy it, paste it up here, we have something that looks like this. And these here. And I know my drawing, this force resultant should be the same. But if you can see, this down here is what we drew over here. And this up at the top is what we drew here. So all we're doing is copying and pasting those two vectors head to tail. And so we can compute our force resultant. Now, something you want to think about, if you have a protractor and a scale, you could draw these to scale with the protractor and actually measure out the force resultant, and you could actually measure out the angle and then check your work compared to that. So on the next videos, we're going to do a couple of examples, and so